What's up, everyone? We are live and back with another episode of the Trainman Report, your local NDG podcast that covers the most local NDG stuff that mostly Alex Montagano thinks of. That's right, y'all. He is on a passion. He's like, here's our next guest. Here's our next guest. Everything's ready to go. He's getting props for the show. Like we're not just allowed to come in regular attire. Our guest today, Mr. Andrew Higgins, chose not to wear his props. That's okay. Our guests don't have to follow the rules. I unfortunately have to follow the rules. That's the way the Trainman Report goes. So you can let us know what you think about the props in the comments. We know that we are live on all the different platforms of Twitch. We are on YouTube if you want to follow us there. We're also on Alex's Facebook page, and that gets shared to everyone's favorite local Facebook group, Thrive NDG, because up on this podcast, that's the most popping place there is. That being said, we're really, really excited to be here. Make sure to leave comments along the way. We'll try to answer any questions you may have, and let us know what props and helmets and other such gags and goofs we should embrace in the future. Oh, yeah, that being said, sure. Alex, would you like to do your gracious introduction of our guest today?
Absolutely. As you know, this show has had the pleasure of having really smart people on it, as opposed to myself. And Andrew Higgins is the second guest that we have had on the show, who is another level. Remember Mr. Hogg? He was an MIT Harvard graduate. And today we have Andrew Higgins, who's a McGill professor. And he's a professor of mechanical engineering, believe it or not, with master's and PhD degrees in aeronautics and astronautics. So to put it in simple layman terms, he knows how to blow things up. Is that a correct description there, Andrew Higgins?
Yeah, I've blown a few things up. Yeah,
controlled explosions, if I could use that expression, right? So he's worked in McGill University. He teaches courses on compressible flow. So you compress something, and I suspect that means it's like you compress it, and then it kind of.
Alex, can you bring your mic a little closer to your mouth?
Oh yes, it exhausts from something. There you go. Right? Here we go.
Yep.
Thermodynamics, combustion, and statistical mechanics. Okay, there we are. He has worked 30 years on research in high-speed flow and shock waves for applications to aerospace. It's still too low?
Oh, no, I said that's so cool.
It is very cool. This is cool.
But I said
stuff.
It quietly to not cut you off.
Very, very nerdy, off the charts. I have a very nerdy side of myself. Well, it's kind of evident, right? I'm wearing a Trainman uniform. And so I haven't finished aerospace propulsion and fusion energy, and he's also a cyclist. So he's an urban cyclist in Montreal, and most importantly, he is an NDGer. You live in NDG, so yeah. I am really beside myself that all us NDG nerds and geeks have like sort of a hero, an icon to look up to, right? And this is Andrew Higgins. He's figuring out how to travel between stars, ladies and gentlemen. This is not going to Mars or the moon or any stuff. That's kids' play. This is going to the next star system, okay? This is Star Trek. This is Star Wars. This is like that kind of level of stuff, right? So this is really cool. I'm very excited. But before we get on our show, I just got to do some little community announcements. I apologize for that, Andrew. No. Remember Holden? Did I just call you Owen? Holden.
You did call me Owen, yes.
Holden, remember we talked about how we're going to give regular shout-outs at the Wheel Club. The Wheel Club, Andrew, if you don't know, is our local entertainment, live music entertainment venue. They're on Cavendish Street. They're just below Sherbrooke. And this Friday, there's the Fabulous Flashbacks dance party. So this is a rock and roll party for Friday night. It's going to be a great time. And then Saturday, they're celebrating Mardi Gras in Montreal with Dave Lines, Pat Loisel, and the Louisiana Night Train. So there's a Louisiana Night Train band playing there. So I think that's a calling for Trainman maybe to come out and partake in those festivities. So. And most importantly, or not most importantly, I should say, coincidentally, I'm a big backgammon player, and I discovered there's a backgammon cafe that just opened on Sherbrooke, 6380 Sherbrooke West. I participated in a tournament there last Saturday, and I had a blast. It was a great time. People were so friendly. And I want to encourage all people from NEG to go and patron this establishment, because I want this establishment to be successful, and I want us to use it as a vehicle for us to socialize again. So, bam, back into interstellar travel. Yes. Oh, Andrew.
Oh, hold on. Before we go back in, we're going to go. If you want us to bring up your establishment / service / thing related to NDG updates that you would like shared on the show, definitely reach out and let us know. Because, in order for the Trainman report to be complete, there really should be a plug the community section. So we're trying to evolve it over time. Definitely let us know also what ideas you have. And yes, let's go back to the space.
Alrighty. So, to boldly go where no man has gone before, right? I quote Captain Kirk. So,
NDG former resident, by the way.
Oh, yes, absolutely. Yeah. And McGill, I think he went to McGill as well. The Union building is named after him. It's the William Shatner Center. So
he went to Willingdon Elementary, and then he went to Montreal West Hill High School.
Yeah, it's awesome. So you see, NEG was meant to be in space. It's what it is. So going on, when we talk about space travel, right? And we were watching these sci-fi movies, films, and franchises. There's always this talk about warp speed and light speed. And, why don't we start with that? Like, there's really challenges at traveling that kind of speed, like how to get that fast. So you're the expert, you're the genius. So please fill us into the limitations or the challenges related to light speed.
Okay, so first off, I do have my prop here. I brought a prop, but I'm not ready to uncage the beast yet. It'll come out in a minute.
Okay.
So when you're talking about going faster than the speed of light, like warp drive, warping space, that's kind of above my pay grade. So to talk about those things, you're gonna have to talk to a theoretical physicist, which we probably have several of here in NDG.
Right.
That stuff gets pretty funky. So that's involving, Einstein's theory of general relativity. That's way beyond me.
Right.
And those people, when you talk to the people that work on this, so there actually are people that talk about mathematics of warp drives and wormholes. It's really just math. Okay. They're just playing with Einstein's equations, see if there's some kind of solution there. But if you ask them, okay, is this something we can actually build? They'll say, I don't know. They have no idea how to even start doing something like that. They need negative energy densities and conditions that don't exist outside the Big Bang. So
when you say it's like a question of math, then right, is that like they just kind of are trying to literally solve equations and they cannot solve these equations? But if they were to, in theory, solve one, then they could move forward towards building something that would be able to go at warp speed.
Yeah, there's a physicist named Miguel Alcubierre who some decades ago, 20 years ago, actually came up with a solution of Einstein's equations of relativity that could actually create a warp bubble. Okay, but it's just a piece of math. Okay, he just played with the equations, and from physicists I talked to, they're kind of impressed that he was able to do this. But then if you ask, is this something we can actually build? People have no idea where to get started. The energy densities and to warp space like that, it's the sort of things that happen at the edge of a black hole. It's not something we can ever do in the lab. So I'm an engineer. So when you're an engineer, you got to kind of stick to the rules that are given to us in our physics textbooks. So what I and my group at McGill is working on is there things we can do with the engineering and the physics we know today that could get us to the stars, and it's not going to be at light speed. So as you know, as you get faster and faster, it takes more and more energy. If you remember one thing, there's only one equation, maybe two. It's the energy of an object is 1/2 times the mass times the velocity squared. So when you get faster and faster, that velocity squared term gets crazy big. And as you get nearer and nearer the speed of light, relativistic effects come in, and it just takes too much energy to go that fast. So what we're thinking about is maybe going 10%, 20% the speed of light. That means it's going to take decades to reach even the closest stars. So probably not humans, at least not for now. But there's robotic probes we've sent out. There's Voyager spacecraft. It's been going 50 years. It's still sending data back, and there were scientists that were patient enough to do that. So we could probably think about doing a mission like that, like a robotic spacecraft we'd send. Would take decades to get to even the nearest stars, but it would still be pretty cool to get pictures back of exoplanets.
So what I'm hearing from you is that there's a theoretical side of astrophysics and of light speed, but then there's the practical realities that confront us in the world in which we exist. And
Right.
you're a man of practical knowledge and practical ideas, and you're coming with up practical ideas based on the technology and the available resources we have today to make it to the next star system. So you're saying that if we get to 10-20% of the speed of light, that would be enough, say, in a decades-long mission to get humans to the next solar system. But the problem is we definitely need to send a probe first, because if we're sending this, it's going to be a one-way trip, right?
Yeah, yeah.
Those
And it'd
people
probably
are
even be like a flyby, right? So when we sent the first probes to the other planets, to the moon, Venus, Mars, the spacecraft just flew by, took a few pictures, and that was enough. And
Right.
then they figured out how to go into orbit and then do landings and so on. So right now we're just thinking about just try to do a flyby, to nearest star. We now know the nearest star has a planet around it.
Right.
The nearest star is called Proxima Centauri. It has a little planet that's orbiting actually in the habitable zone where water might exist.
They call it the
But-
Goldilocks zone.
It's exactly. It's in that Goldilocks zone. We have,
Right.
but astronomers will never be able to show you a picture of it, right?
No.
They can maybe get like 1 pixel of it, but to see what the planet actually looks like, you'd
Right.
have to send a probe there. There just never be a telescope big enough to do that.
That blows me away.
So that's like the next like main quest for like what space exploration is looking into, right? Because I mean, my understanding is we see what Elon does, but we don't really see what the science side of space exploration is really looking for towards. So we've been able to identify a target, like something that is attainable, that if we were to prioritize it as whoever government agencies or funding does it, we could build something, send it there, and then like in 30-40 years we can come back, reconvene, and take a look at the pictures it gets.
Exactly. Yeah. Right. So there's
That's
not that many
really
people
cool.
thinking about this. Most of the planetary science community and astronomers, they're still exploring our own solar system, but there's some of us that are getting a little bored with the solar system, right? So if you want to know what it's like to go to Mars, you can put on your Oculus Rift goggles and you're there. Okay, we've mapped the surface of Mars to like 1 meter resolution. We've had rovers there. So if we don't know what Mars is like, or basically any place else in our solar system, we have a pretty good idea. But I kind of want to get back to like those real voyages of discovery where you go someplace you have no idea what you're going to find.
Yeah,
And that's kind of what interstellar travel would be.
Imagine.
But it's going to be clear, this is really, really hard. Like
Is it possible then, because you said Discovery and then I started thinking of Star Trek, and I was like, so typically in a lot of these shows, when you watch the timeline, they end up getting this new way to create energy that's at like an astronomical level beyond what we've been able to do, which allows them to then build warp drives and other such fun technology. Is it like possible then in the reasonable future that we discover something, whether it be on Earth or somewhere that we can measure right now, that could turn into a catalyst that will bring us to a higher power output so that these trips would be significantly less? Because we're not sending people, there's a lot less risk in terms of experimenting with a higher, approaching the light speed at a higher point.
Yeah, maybe you could find some source of energy out there. There's some work my group is doing where we're playing around with ideas about how you might be able to tap into energy sources like the solar wind or the interstellar media and use those for propulsion. But it's pretty speculative at this point. So
Right.
So to back up just a little bit, the reason why I was so intrigued by you, and one of the reasons, or the thing that triggered me asking you to be interviewed today, was that I posted a picture of the moon and Mars on the horizon, and you said that your gaze was you had a farther gaze than that, right? And my question to you is, on a personal level, what prompted you to have this interest in interstellar travel? What inspired this NDGer to think of the next star system and how to get there? What started all that?
Well, I mean, like most people that you talk to that work in the field of space, it was growing up watching Star Trek. Okay, so I probably watched the same Star Trek
Let's
Alex did,
go.
where it was female crew members wearing cocktail waitress outfits, and
Right.
the captain's
Times
the
have
captain's
changed.
idea of diplomacy was a smirk and a phaser, right? That was the Star Trek we grew up on. But yeah, I grew up on Star Trek, and then I watched Carl Sagan's
To go
Cosmos, and
to the
then
next system.
and then
Kirk.
I watched through the 1980s. I watched the Voyager spacecraft I mentioned earlier. It is one spacecraft, Voyager 2, visited Jupiter, Saturn, Uranus, Neptune. And I remember as a kid and a teenager watching this and watching these scientists, when the first images would come back, they were just like, oh my gosh, like
Blew me
they
away.
found each one of these little solar systems, each one of these little planets,
Right.
not little planets, these gas giant planets,
Right.
had its own little solar system orbiting it. And they didn't expect
Moons.
that. They found moons with volcanoes, active
yeah.
glaciers, geysers, all this stuff. And I'm like, oh man, I would love to be a part of this, but I was a teenager, right? And then it was kind of done. We have visited every planet in the solar system now, and so there's a lot left to be done. But if you want to get back to like that golden era of exploration, you gotta cast your gaze further. You gotta look beyond our solar system and start thinking about going interstellar.
I like the way you think. Now, going on, one of the things that I saw you in a prior interview, and I did some background work. There's always the problematic, right? You've got this rocket. How do you get it, into space? And then there's obviously the needs of the crew itself, or, maybe let's forget the crew at this point. We're talking more of a probe, right? Engage,
Right.
release the probe, right? All that stuff, right? I had to say that. I'm sorry. So there's a lot of talk about the rocket equation, right? And then you also are discussing, I heard, these ideas of using a sail, but it's not a solar sail. It's different. You're not catching the solar winds. You're catching something else. If you could talk about that, and antimatter. So how do these things all, like the rocket equation, antimatter, and
Okay.
just give us a real dumbed down version of it, because like I said before we started this, I'm a dum dum, so I need some way to digest that all.
All right. Yeah, it's actually kind of embarrassing. It's a little embarrassing how simple this stuff is and how little you need to know to understand space travel. It's not all that complicated. So
I'm feeling better about myself. Go ahead.
okay, so if you're going to go really, really far, you got to go really, really fast, right? So if we're going to go to the nearest star system, we got to go like 10,000 times faster than our spacecraft today.
Right.
And if you try and do that with a rocket, the problem is a rocket carries all of its own propellant. And the faster you want to go, the more propellant you need. But if you're carrying that propellant, then you need to carry even more propellant to launch that propellant. Okay, so it's this vicious cycle. As you want to go faster, okay, more propellant, but you got to bring that propellant with you, and pretty soon the amount of propellant you need just blows up exponentially. And that's what the rocket is. The kind of this, we call it the tyranny of the rocket equation. It has this exponential dependence of how much propellant you need, depending on the velocity you want to get to. So pretty quick, you realize, okay, there's no way to get there with chemical propellants like hydrogen, oxygen, like that's used on the space shuttle. There's no way to get there even with like ion drives, electric propulsion, these things that are starting to be used now. If you've ever seen one of these SpaceX Starlink satellites, it has electric thruster on it. That's not going to get you there. So probably the best play, like plan A, I like to call it, is forget rockets altogether and keep your energy source back on Earth. Okay, so propellant, do leave home without it. Okay, so the idea is your spacecraft is basically just a sail, and you're going to build a giant laser on the Earth. I mean, big, like 10 kilometers big, and you're going to beam that laser onto this very thin sail. It's as thin as saran wrap. It's got a reflective coating on it, and when that laser bounces off, that imparts a little bit of pressure. But the cool thing is you can keep pushing. You're not going to outrun that laser beam because it's moving at the speed of light. So you just keep pushing that sail with the laser. And if your spacecraft is really light, like maybe 1 gram, within 3 minutes, you can push that sail up to 20% the speed of light. And that's the speed we need to get to the nearest star system in a couple of decades. So that's kind of plan A. And there's some serious money and engineering going into that now. So that's pretty cool. You have any questions about that? You follow all that?
I follow
Hold
that.
on.
That's really cool.
So if I understand correctly there, you're saying that you need to make a tiny, or when I say tiny with regards to weight, very light like an object that could measure stuff, and then put a giant, very thin sail, literally a sail. Like
Yeah,
you
the
would have
sail
on
in the
a boat.
spacecraft may only be a couple meters big. Okay.
Right.
And you might say a gram, that's ridiculous. You know, what can you do with a gram? But think about these things. You know, think about these smartphones we all walk around with right now. You know, the computer power on this phone is more than the computer power on the entire planet 20 years ago. You know,
Right.
So think about when we're ready to launch this mission, which is not going to be tomorrow, it's going to be in 20 years. Think about how powerful computers will be. Think about where AI will be. So,
Right.
you know, you could probably pack quite a bit and do a little 1 gram chip, a little, you know,
Do
star
we
chip.
have
we're gonna send.
materials that could be that thin that could be used as a sail that would survive space? Because my first thought is like, how does it navigate through space debris?
Yeah, it's a concern. That some of the work we're doing at McGill is worrying about that. Like a big concern is when that laser's on, if that sail were to hit something and maybe shatter a little bit of the sail, then that would no longer be very reflective anymore, right? If you crack a mirror, it doesn't reflect light anywhere very well. And then it would start to absorb some of that laser, because this laser, I don't know if I mentioned it, is going to be big. Okay, it's going to be like 100 gigawatts of power coming out of that laser. And if you damage the sail, you might just vaporize it. So I had a student at McGill do a thesis on this. And what we showed is if you make the sail a little bit transparent and let some of the laser light through, it would actually vaporize the little dust grains before they hit the sail. So it would kind of like clear out its path, like a cow catcher on an old train. It would kind of clear a path out in front of it.
That's
and
a great idea.
That would protect the sail, at least when the laser's on. Then when you turn the laser off, maybe you turn the sail sideways and fly it edge on so it doesn't get hit by as much, you know, dust.
Why
dust
would
grains.
you ever want to turn the laser off? Don't you just want to keep on pushing that thing?
Yeah, you would love to, but unfortunately, even a laser, even the most perfect optical laser you can build, the beam starts to spread out. Okay, so if you take your laser pointer and point it across the room, you're like, wow, there's a little dot on the wall. But if you point it on the neighbor's house, don't. But if you do, the dot gets bigger and bigger and bigger.
Right,
and even if you make the most perfect laser, the beam is going to spread out.
It's going to get diffused at some point.
Exactly. Yeah. It's the diffusion or diffraction of light.
But the diffusion and diffraction of light is what you speak of. That means that at some point its capacity to push the space craft will be negligible. You'll ramp it up, and once it's ramped up, it's done. The exercise is over from a thrust perspective.
Yeah. Then you turn the laser off. But what's cool then is you can launch the next probe.
Right.
So if it only takes a few minutes to launch this, we could just shotgun these things to not just one star. We could send them to all the nearby stars, and you could launch a lot. So maybe if one of them does hit a dust grain and gets vaporized, you just keep launching more and more.
Yeah,
so the big ticket item is building that big laser.
But you need But you need more than one laser for that. No.
No. You just use the laser the next day. You don't even have to run the laser for a few minutes to get it up to the 20% of light speed. And then, you recharge your batteries to probably be solar powered. So you run your solar power overnight, charge up your batteries, and then beam.
Okay. I'm thinking that you have this beam on this thing for a year or something.
No. You can if your spacecraft is just a gram, you can do it in a few minutes. It's crazy,
but why wouldn't you just attach the sail then? If after you've got it up to 20% of light speed, just get rid of it, and wouldn't that increase the thrust even more because you're actually losing part of the mass? Right?
Yeah, but you need the sail as a reflector. Once the laser's off, you could throw away the sail, but it's probably useful to keep it around. You might be able to use that. The sail might also have like solar panels integrated into it, so you could, when you get to the next star, you could get some power.
But how would that thing communicate with us? Is our the radio transmission technology? Because I know they're having problems with Voyager now communicating with it. They're starting to have problems, and Voyager. We have to cut some slack to Voyager. It's a miracle it lasted this long.
I know, 50 years, right?
I'm not going to fault it, right?
Yeah, I'm about the same age, and I'm starting to show some wear and tear too. Yeah,
exactly.
So you probably wouldn't use a radio to send the data back, but it turns out a little tiny laser transmitter, like a 1 watt laser transmitter, like what you use in a laser light show.
Right.
That if you have that on the spacecraft and you beam that back to Earth.
Right.
You could pick up that data with the telescope, and you could. My colleagues have shown that you can transmit like HD quality video.
Really?
From a little tiny spacecraft, flying through another solar system.
It could do a flyby of that Goldilocks planet, the next
Yeah.
solar system, and we can get like high def images of what its atmosphere and its terrain looks like.
Exactly.
Oh my
And
God.
it's going then, because it's using the light, it's going basically at the speed of light to travel back here, right?
Oh
or would
my
it be
Yeah.
slower?
We have to wait 4 years to get that picture back. Yeah. But it took 20 years for the spacecraft to get there. So.
Imagine.
That's like something we could have in our
Just
lifetimes.
imagine. This
Yeah.
this is
In
blow.
theory,
This
in
is
theory,
blow.
if it were to like launch in the next little bit, like that's really cool.
This is blow my mind away kind of stuff, because there's this theory out there that if you have liquid water, right, on a planet in an environment, you'll have life. So if we send a spacecraft, a probe, right, release the probe, and it arrives to the next star system, and we discover life, if on this planet, then that means almost every solar system we look out there has a potential, a high potential of life existing. Is that a correct statement?
That's right. Yeah. I mean, almost everywhere they look now, they're finding planets. So when I was a student 30 years ago, they used to say, well, maybe there are no other planets. Maybe we're the lucky one. Maybe forming a stable solar system is like flipping a coin and having it land on its edge.
Right.
But now we know there's exoplanets like everywhere, planets in the habitable zone, and we're going to be finding more and more. But all astronomers will be able to do is just show you like a dot. It'll be like Carl Sagan's, pale blue dot, just like this pixel. And they can learn a lot from that. So what they'll do is they'll take the light from that pixel, they'll pass it through like a prism, look at the spectra of the light.
Right.
And they'll be able to say, like, maybe there's oxygen there, maybe there's methane in the atmosphere, but that's about as far as they'll be able to go.
Right.
And if you want something more than that, like you want to see like a megapixel image of a planet, you're going to have to go there with a probe.
So with the probe, can I
probe.
just ask a question about the probe? So we've sent the probe, you've got it to its 20% of the light speed, and now, if I'm not mistaken, because it's in space, it'll just maintain the momentum of that speed indefinitely unless something literally gets in its way.
No
so
friction.
As long as it has no disruptions, you only really need that 3 minutes, and then you're good, and you could really launch these things 365. And then because the Earth is also spinning, you can just always target whatever angle you need any day of the week, depending on it. You just have to have the perfect timing to sync it all up, which 20 years from now's AI will probably do really fast, arguably.
This is really cool stuff. So we're getting away from like propellant completely with these theories that you're proposing. It's like we're not exploding anything here. These are not controlled explosions. This is really Earth-based energy source pushing, and it makes a lot of sense. It really, I think it makes a lot of sense.
Okay, so that's one way to do it. But if you want to get back to explosions, there's another path to the stars. So this is what has me excited: is if it was just this laser-driven sail,
right?
If that was, we put all our eggs in that basket. It like I think Holden hit it right on the head when he asked about what happens when we hit these dust grains. Right. And that's actually what I lose sleep over at night. I mean, I will lay awake for hours and think about, oh my gosh, what if there's dust grains? What if there's dust grains?
This is what's happening to the James Webb Telescope.
It got hit. Exactly. It got
by
nailed.
Debris. Yeah,
by a dust grain.
Yeah.
So if you want to bring a beefier spacecraft that you could have some like serious shielding on it, then the laser-driven sail approach doesn't look as good. If you want to launch a bigger spacecraft and you want to use a rocket to do it, there is one fuel that's out there that could do it, and that's what brings us to antimatter. So that's the one possibility where you take matter and antimatter and combine them together, and that's the other equation I'm going to use is Einstein's E equals mc squared. So when matter and antimatter hit each other, you get complete conversion of mass into energy. And if you can exhaust that out of like a big magnetic nozzle, I mean, that's going to be crazy pions and mesons and all kinds of energetic particles.
Yeah.
What is antimatter?
Okay. So antimatter, first of all,
that doesn't sound real to me. It sounds like some blah blah.
Okay. So this is, I'm ready. I'm going to drop the beast now. So antimatter is real.
Right.
And I'm going to show you a source of antimatter. I have it right here. You ready?
All right. Yeah, I'm scared. Okay, go.
Get ready for yourself. Okay, this is it.
Banana.
Yeah.
So
for people who are listening in, if you have a banana in your kitchen,
wait. The whole like mood of this interview changed. Now, welcome to space travel.
All right. So yeah, the banana is antimatter.
We're-
I'm
Okay,
curious
no,
about
no.
how
So
antimatter-
Wait. Let me finish. We're traveling through space in wrong rockets with bananas.
Okay, so if you have a banana in your kitchen,
Right.
about once an hour, the
Right.
potassium. Why do we eat bananas? Why are bananas good for us? What do they give us?
Potassium.
Yeah.
Potassium, exactement. So there's an isotope of potassium in your banana called potassium 40, K40, and about once an hour, one of those atoms is going to disintegrate in a way that it generates something called a positron, which is an electron, but rather than electrons being negative, it's an electron that's positive. It's like a mirror of ordinary matter. So in antimatter, the electrons called positrons are positive, and the proton in the nucleus, called an antiproton, is negatively charged.
Okay.
So it's like a weird mirror of normal matter. And in your banana in your kitchen, that positron, when it meets an ordinary electron, it actually annihilates by E equals mc squared and sends out a gamma ray, okay, which is like crazier than an X-ray. It's a really energetic electromagnetic wave, okay? So it's safe. You could wrap yourself in bananas your whole life, and your radiation exposure to that is negligible, okay? You get one dental X-ray, and you're going to get more radiation than a banana is ever going to give you,
Right.
okay? But it's real, okay?
But,
and
so
if you've ever known anybody...
Bananas are
Yeah, go
just
ahead.
spamming us with radiation at negligible amounts all day.
Right. Yeah. So over the course of this interview, there's probably inside this banana, a positron was formed by the decay of potassium, met ordinary electrons, annihilated each other, and a gamma ray shot out. Okay. But it's at a low enough frequency, I don't have to worry about it. Okay. If you've ever known anybody that's got a PET scan, if you've ever had any like a relative that had a stroke or something, they
Right.
actually inject into patients a more intense radiation source that generates a lot of these positrons. So that's what PET scan stands for, positron emission tomography. And it goes inside their body, tends to collect in for example, it can be used to find tumors. And when the positron comes out and meets an ordinary electron, it makes a gamma ray. The machine can see that light, and that's where it figures out your tumor is, or if you've had a stroke where there's blood not reaching. So it's absolutely real. Antimatter is absolutely a real thing. It's used in medical imaging technology every day. Okay, so these positrons probably aren't that useful for propellants because they make gamma rays, and gamma rays, we don't know how to reflect them or use them. But there's an equivalent of the proton called the antiproton that's made at big particle accelerators, like the Large Hadron Collider in Europe and the Fermilab accelerator near Chicago. They make this antiprotons, and they can make antihydrogen. They've done it now. They've made antihelium, and in principle, you can make like an ice of antihydrogen, and you could make a lot of it. Now they make it in like picograms because that's all the physicists want. They don't want to make kilograms of it. But in theory, we could make an accelerator that would be a factory for antimatter, and you could make, it would cost, like the Large Hadron Collider, it costs $1 billion a year to run. But over a number of years, you could build up enough antimatter and use that like propellant, like rocket fuel for a rocket. And that rocket could actually get us to the stars. You would need like maybe a kilogram to launch a robotic probe to the stars.
And how
So
long?
that's a
how long-
completely...
But
How long would it take? Yes, sir.
go ahead.
Go on, Alec. I was just say, how long would it take to get a kilogram of antimatter with our current technology?
I mean, like right now, it would take us centuries. But I'm not an expert on this. But there's people in our interstellar research community that one of them used to work at Fermilab. He was in charge of antimatter production, and he's come up with designs where you'd make a dedicated accelerator just for making antimatter. And you could probably make, for the same cost as our particle accelerators today, you could make, 100 grams a year.
Wow.
Once you get 10 years, you'd have 10 kilograms. That would be enough to probably launch a small robotic probe.
Yeah, but
So what's cool about this is a completely different independent path that could also get us to the stars. So if the laser light sail doesn't work out, this could be like our plan B.
Right.
And I got a plan C and a plan D as well. Okay, so we have other ways.
But say if you got this antimatter engine, right? You got this rocket going through space. Now, say you get it up to 20% the speed of light using the antimatter. doesn't, space dust at that speed hitting anything, any particle at that speed, isn't that still a danger, a hazard nonetheless? How do you?
Yeah, so just if you had a bigger spacecraft, you could probably have some shielding in front of it. So
But it
kind
would
of like how we
protect
protect the.
Yeah, but it would protect you at those speeds.
Yeah, I mean, kind of how we protect the space station is we have something called a Whipple bumper. So we have a shield that's about 30 centimeters off the space station.
Right.
And if a piece of orbital debris hits that, it gets vaporized. And all that hits the hull of the space station, then it's just a vapor cloud, which can still do damage, but it's much easier to stop. When you're going 20% the speed of light, probably what you could do is have a shield way out in front of you, like hundreds of meters out in front, because everything's coming right at you, right? It's like driving through a snowstorm at crazy high speeds. The snow is coming right at you.
Right.
So if you have a shield out in front, that's where it's going to get hit. And then that thing gets vaporized into a plasma, and then you just have like a magnetic field around your spacecraft and just deflect that plasma away. So that's maybe one idea.
It would be like when they are in Star Wars or in Star Trek and they're traveling at light or warp speed, all the stars are like...
just coming straight at you. So if you're going to get hit, where you're going to get hit from. It's from the front. You don't have to worry about the sides and the back. So it's relatively easy to shield yourself if you know exactly where the...
Is it possible to invent like shielding technology like they have on Star Trek that would like put like just like a barrier of some kind around the ship, or is that
maybe
there's
too
science fiction?
No, there's people working on that now because already once you're outside the Earth's atmosphere, you're getting hit with cosmic rays all the time. So, and the space station, especially when they go outside the Earth's magnetic field, like when we send our astronauts to the moon next year, and Artemis 2, they're going to be getting hit by cosmic particles that are moving at like 99.99% the speed of light. And that's a little scary because that will increase their cancer risk. So there are people doing research now on maybe putting a magnetic field around a spacecraft to protect it from particles. So some of those technologies, if they work out, we might be able to use those to protect the spacecraft from the secondary particles when a primary particle hits the shield in front of the spacecraft.
So magnets could ultimately be like a snowplow for space.
Yeah. Magnets are good at kind of scattering particles away. So.
Can you mine, like, I just hypothetically, could you mine antimatter from banana?
Actually, banana probably not that efficient, but there have been some studies. I know the people who did this.
What about pickles?
You could maybe mine it from places in the solar system. So one thing is like actually the rings of Saturn actually is pretty promising because again cosmic rays hit those rings of Saturn,
right?
And when they hit, it's like a little particle accelerator, and actually there's antiprotons produced from those collisions. So it's pretty tricky to collect them. But there's been a couple of studies that NASA has funded to look at collecting sources of antimatter in the solar system, but probably pretty tough. Probably the first plan should be to...
Is like antimatter like the next like nuclear technology? Is that kind of dangerous? That stuff?
Okay, yeah. So I want to get this because if you bring up antimatter, I know what's going to happen because I've done interviews before and all the comments fill up with, "Oh, this is too dangerous," and so on. So let's go through this. Okay.
Right.
So we got to make like a lot of antimatter, and then we're going to freeze it in a ball of antimatter ice. Okay,
right.
So we can store it, and it's going to be stored in a vacuum chamber.
Now we need antimatter ice, but go ahead. Yeah, I'm listening.
Right. Okay. and we're going to keep it in a vacuum chamber. It's going to be magnetically suspended. So we know how to do that. So it doesn't touch any walls.
Right.
But then people will always say, but what if a tiny little speck of ordinary matter hits it? It'll be like a bomb going off. Okay.
Right.
If a tiny little speck of ordinary matter hits it, it is going to annihilate and turn into E equals mc squared. But that's what's already happening in my banana. Okay. If it's just one particle, we can tolerate that.
Right.
Now, if you slam like a chunk of matter into a chunk of antimatter,
right,
let's not do that. Okay. So let's just avoid doing that.
But what would
even
happen,
if you did that, I don't think it would be a bomb. I think what would happen is they just push each other off. So they would annihilate right on the surface, but they push each other off. So there's a experiment you can do in your kitchen that's very similar to this. If you take a frying pan and just put it on your burner and get it hot, like get it glowing red hot, and then pour water onto it.
Yeah.
The water actually doesn't boil. It gets suspended above a layer of vapor.
It jumps.
It's called exactly.
Like a ball.
This is called the Leidenfrost effect.
Right.
And if you took matter and antimatter and slammed them together, it would probably be, again, don't do it at home, but if you did slam matter and antimatter together, it would probably just repel each other off.
We used to do that as a kids with the wood stove. We would like throw some water and it bounce around on top.
Yeah,
of
and
the
it'll
burner.
drop, just sits there. You can just sit there for a long time because it's sort of insulated by its own vaporized layer. Okay. And then the last thing, let me get this out, is, could this be used as a bomb? Because there's this certain book by Dan Brown that was made into a movie with Tom Hanks where they I'm not going to give away any spoilers if you haven't seen this. But that movie did a lot of damage to the antimatter interstellar propulsion community, right? Because it implied that a tiny amount of antimatter would, you could do bad things with it. Okay, so anybody who tried to do that would probably just bankrupt themselves. Okay, so antimatter is going to be so expensive to produce that it would be just much more efficient to build the kind of mega death weapons that we already know how to build. So if you really want to do some damage, it's not that hard to build a hydrogen bomb. Okay. And a hydrogen bomb actually releases more energy than it takes to make it. Okay, because you're actually burning.
This is not a recommendation.
No.
Right. So it's actually burning. Like a hydrogen bomb is actually pretty energy efficient because it burns deuterium and tritium. Okay. Whereas antimatter is just a battery. All the energy you get out of antimatter, you got to put into making it. Well, so it's just not that efficient to do it as a weapon. You would only make it if you had a big international consortium that could afford to build like, a large hadron collider facility to make it.
Okay, fair enough. But the next question I have, and I don't want to spend the whole interview on antimatter, but it's kind of cool.
It is a good topic.
It's cool, like antimatter. What the hell does that mean? But is that antimatter? Is that a naturally occurring like substance matter, or is it something that we're producing, manufacturing ourselves? You know what I'm trying to say? Because there are elements out there now that we are artificial. We've created them, right? That are not naturally occurring. Is this what antimatter is about?
Antimatter is like you take the periodic table and you hold it up to a mirror,
right?
And everything that's positive becomes negative. So there's anti-hydrogen, anti-helium, anti-lithium.
Okay.
And where is this stuff in the universe is a really good question. And you're going to have to ask a physicist that question because they're actually arguing a lot about this. Because at the Big Bang, there should have been equal parts, right?
But when I went to high school and we studied the periodic table, right, and the elements, antimatter never came up in any conversations. Like I'm an old man now because that was 30 years ago, right?
It's because we just don't find it naturally.
It didn't come up when I was in high school either, and I'm in my 30s, so
because it just doesn't have that much of an application other than this PET scan that I mentioned. It's not industrially that important. But it's a deep question for physicists and cosmologists. They worry about this. Like, why are we in a matter universe, not an antimatter universe? Why one, not the other? And I don't think they've resolved that question yet. So that's something
So it's more of a philosophy issue.
Right. But for me as an engineer, it's just like a really good battery, right? It's like the best battery you could ever make. It takes a lot of energy to create it, but you get all the energy back when you combine it with ordinary matter, ideally in a combustion chamber or a rocket engine. You spritz in a little bit of that matter, a little bit of the antimatter, and you can get exhaust coming out at very high speed, which is what you need to make a really good rocket that can get us to the stars.
So that would be more powerful than, say, a nuclear propulsion system then.
Yeah. So even like fusion, if we could figure out fusion, probably wouldn't be a good enough rocket to get us to the stars. It's just
so saying that, like, going after just in a resume of the interview that far, right now we're discussing ways of getting a probe to the next solar system to take a look-see, right? It's not really, we're really not the stage yet of sending humans to the next star system. I guess the next destination from us, from a human perspective, would be Mars, right?
Which, if you want to go in a really cold, dry, dusty,
what's the point?
This whole surface of Mars is covered with.
I think we have to figure out terraforming, I think, first before we go to Mars, right? That's my.
Yeah, the whole surface of Mars is covered with like these peroxides that would actually burn your skin. It would give you a chemical burn if you touched the surface of Mars.
Right.
So I tell my students, look, by the time you graduate, Elon is already going to have his 1 million-person city on Mars. So if you don't want to go hang out with eccentric billionaires, cast your gaze further and go to the stars. right? That's why.
This is my point completely, because Mars we know is already taken. My big aim and big goal here is how do we get NDG people to the next solar system where there's actually maybe a planet there that's habitable, right?
Yeah,
And
we could create as eclectic and hip a culture as we have here in NDG, right? Because I
exactly.
think we know when we get to Mars, who's already going to be there. So
Yeah, it's gonna be a wasteland, right?
I mean, is Mars not big enough to share? You know, we could have different corners of Mars, billionaire row, regular people, alley.
No, this perspective is generated 100% by spite and the love for NDG. So continuing along that the whole space idea, like you're an engineer, you're figuring this out, and you propose two solutions: the antimatter solution and the propulsion system, and the sail solution with a laser based on Earth. Sitting there in your chair right now, being the brainiac that you are, and evaluating these two propulsion systems. What's your preference at this point in time? Is it antimatter? Is it the sail? Is it a combination thereof?
actually, what I'm really stoked about is we're working on Plan C.
Okay, you got a Plan C.
So Plan C is I'm going to get around to answering your question. Can we find sources of energy in space?
Right.
So do we need to make the energy here on Earth?
Right.
So we've been working on something at McGill I'm pretty stoked about. So this is pretty out. Maybe take a couple more hits from the bong before I get to this one, okay? Because this one's really out there. There's a wind
there, Alden.
there's a wind coming out of the sun.
Right.
Charged particles.
Right.
Okay. And it's very diffuse. It's weaker than sunlight.
Right.
But because they're charged particles, the solar wind, we can interact with them using magnetic fields.
Right.
And so our students in our group at McGill have figured out that there's a way you can like surf or sail on this wind, and that alone would drag you up to the speed of the wind, which is fast. It's moving like 500 kilometers a second, which is 10 times faster than any spacecraft we've ever launched. Not fast enough to get us to the stars.
Yeah, but
there's different.
Yeah, what percent?
Yeah, that's like that's nothing. That's less than less than 1% the speed of light.
Okay.
That's not going to get us there. That's just over 0.1% the speed of light.
No, we need to
right. But this is what's cool now: is there's regions in our solar system where the wind has different speeds.
Right.
Okay, and on Earth, birds, seagulls, albatrosses have figured out that you can tap into regions of wind shear like that and go faster than the wind. And there's glider pilots doing this now. So when this interview is over, go to YouTube and type dynamic soaring.
Right.
Keyword dynamic soaring, and you'll see people launch little remote control gliders that will go into regions of wind shear, and they'll kind of bounce in and out of fast and slow wind here on Earth. And that little glider can get going 1,000 kilometers an hour.
Wow.
Okay, even though the wind is only blowing maybe 50, 60 kilometers an hour, it can go fast in the wind because it's kind of like bouncing between the wind and the still air of the wind. And every time it bounces it's like a train approaching another train and a ball bouncing back and forth. And anytime it bounces, it goes faster.
Right.
So we just published a paper last year.
That really works for me, by the way.
With the Trainman, yeah. I did that just for you, Alex. So we published a paper showing you can do this in the solar wind. You could have a spacecraft that would bounce off different regions of the solar wind, and you could pick up energy faster. And that energy, you're getting it for free. You're getting it from just exploding this regions of two different wind in the solar system.
Using a space sail once again.
Yeah, it would be like a magnetic sail. It would be
magnetic sail.
You have to use to interact with the charged particles. You'd use a magnetic field.
Has this concept been tested? Like, is this a viable...
No, it's all theoretical at this point. So now we're just starting to think about how we could, maybe do a demonstrator of this. Could we launch a small satellite, like a CubeSat, that would start to test out some of these technologies?
There's no way on Earth in a vacuum laboratory environment.
Yeah, it's pretty hard because like space is such a good vacuum. We actually cannot in the lab create a vacuum as good as that is in space. So we're mainly doing like computer modeling. But eventually we'll have to go and test this out in space.
Well, there was some talk about how you could a rocket actually could collect material in its voyage, that actually space is not completely 100% void. There's actually stuff in there, and I don't know anything about
Yeah,
that.
that would be probably be like Plan F or G or something. So there's
Right,
an idea. If you're a science fiction fan, you might have heard of this. It's called the Bussard ramjet. So
right.
if you know science fiction authors like Larry Niven or any of these, they use this a lot. It showed up in there's this famous book by Paul Anderson called Tau Zero, where
Mhm.
they have one of these Bussard ramjets. Um, we don't think that'll work. There's some pretty foundational flaws in that. One of them is the hydrogen that's in space is just ordinary hydrogen. It's just protons, and we don't know how to fuse those. The sun can do it, but we can't do it very efficiently like in a fusion reactor. And the other thing is that the scoop you would need to scoop up that stuff, we don't know how to engineer that. Like Holden was saying earlier, magnetic fields, they're good at scattering particles. They're good at deflecting particles, but a magnetic field doesn't make a very good scoop to scoop up particles.
So that's
It's
off
a
the
really
table.
cool idea, but it's pretty low on my list as to things that might
So
actually work.
your C option right now is by taking advantage of these. You call them magnetic fields. Is that what you were referring them to? Or
Yeah, yeah. So
so
basically, what you need to do is create a little artificial magnetosphere around your spacecraft. So the
Right.
Earth, we don't get hit by those cosmic rays because we have a magnetic field and it kind of
Right.
deflects the particles around us.
Right.
So we have to do some clever things by creating our own magnetosphere, and then we have to sort of stroke that through the solar wind to get power in one direction and launch other waves in another direction. That's what allow us to do this dynamic soaring, to kind of loop around these different regions.
The solar wind is this proton stuff that's
Yeah, blowing out from the sun. Yeah,
blowing up from the sun. It's just from our sun, or is there other like sources?
yeah. Other stars probably have solar winds as well. We don't know because we haven't been there yet, which is why we
Right.
should go. But yeah, we can probably use this technique. And this is getting really time for another hit. Holden, is there's different regions of the galaxy that have different winds and clumps of matter moving at different speeds. So in theory, they say an albatross can fly around the world without ever flapping its wings because it just kind of glides off different regions.
Is that true?
I mean, yeah. I mean, well, albatrosses definitely do this maneuver where they dynamically soar. So they don't flap their wings. They just fly in and out of fast and slow wind, and they can pick up speed and move on. So it's possible. I don't know if anybody's ever.
So you guys are really stoked about this plan. See, you guys think that this is a solution, and it would be cheaper than the
because we don't have to pay for the mega laser for the light sail. We don't have to pay for the $1 billion a year to make the antimatter for 10 years.
Right. So you just need to get a spaceship into space that has the capacity to harness this energy or these solar winds. And you take advantage of the variances and get it up to like 20% light speed and point in the right direction, and off you go.
That's the idea.
But in terms of how would you steer the thing?
Yeah, like any other ship, if you got a tack into the wind, and it would be like a sailboat.
So it'd be like any other modern ship, though. Like you just program a computer to do it, and then set a destination.
You can actually steer off these things. You wouldn't have to have like what do they call them? Thrusters to push you in the right direction or anything like that.
Yeah, I mean, you probably still always have thrusters to do little corrections and so on. But
right.
But like
That
the
is
AI
super
would
cool.
be able to like scan the upcoming like light waves and be like, okay, we need to hit that guy, and then flip over
So
here.
there's actually
go
space
backwards
weather.
This way, go forward.
Yeah, you can actually go on your browser there and type in what's today's space weather forecast.
Is this
and
about
you will
solar flares and stuff like that?
Yeah, and you will see there's NASA spacecraft that monitor the sun and they chart out the solar wind. And sometimes you'll hear an announcement like, oh, there may be an aurora coming up. The Northern Lights might actually be visible from Montreal because there's been a big solar storm and it's blowing a bunch of charged particles our way. And so they can predict this stuff pretty well. So we would need like very accurate space weather reports.
R is at none. I don't know what that means.
Yeah.
S2
but you'll
is
see the
moderate,
wind,
and then G
you see
is
like
none.
a graph there showing. So tell me, Holden, what's the solar wind speed today?
I don't know where on the NASA site. It is not the most user friendly.
If you just type Google, like, what's the solar wind speed?
I did.
I've even done it with Siri.
Like,
I've said, I said, hey Siri, what's the solar wind speed? And she'll answer 347 kilometers per second.
So you hear in the news, it pops up, right, that
Yeah, 422.8 kilometers per second with a density of 4.61 protons/centimeters cubed.
Exactly. It's exactly the information we need to know to launch our spacecraft and start sailing on that wind, soaring on that wind.
You hear in the news about solar flares and how the sun's acting up and how that could impact human activity, like in the sense it impacts our telecommunication systems. Is that a myth, or is that?
Oh no, that's absolutely real. Yeah, there was in the 19th century, there was this thing called the Carrington event. There was an astronomer that saw this giant, emission blow off the sun,
right?
And when it hit the Earth, it melted telegraph lines. It was that dumped that much energy into our ionosphere, and people could read the newspaper. The Northern Lights were so bright you could read the newspaper at night in London from the Northern Lights.
Right.
And if one of those events happens today, we could be seriously effed, okay? Because we're so dependent upon communications now. So those things are predicted to happen every couple, 100 years. There'd be one of these Carrington events. So it's actually something to worry about.
We would see that before it hits us, or it just
we would have a couple days prediction. Yeah.
Okay.
Days.
But there was a big power outage about 20 years ago. I remember it was in August of 20 something in the aughts decade, where there was a big solar flare and it caused a massive power outage across all of southern Ontario. Just all the energy hit the ionosphere and excited electromagnetic waves, and it tripped off all the hydro lines.
But this is the same source of energy that you're seeking.
Yeah, we're trying to tap into it. Yeah, let's use that for good.
That's smart. I like that. That's exciting stuff. That is neato.
It's also really green of you. Like, it's like, I like how your focus is to think about the planet's longevity and to not put a lot of taxing, because the other options sound like they're going to be really expensive to pursue. And if we can just tap into existing, I'm not going to say it's going to be cheap to produce any new technology, but if we can do it in a renewable way that doesn't put a burden on the planet, it's starting to think more long-term with it rather than just burning a bunch of stuff. Because from what I do understand, the current state of satellites launching and everything going on is actually a lot of pollution that is kind of problematic, to a point where, if I'm not mistaken, we have a lot of satellite traffic now going on, and a lot of things like
collisions
that
on orbit
place.
And astronomers are really pissed off at all these massive conconstellations that are being launched that are interfering with all their observations. And
we're
that's why I'm not that interested in
the planet. It's out we've basically done what we've done to Earth, but just in space around the planet, and then we need to figure out a more eco-friendly solution for this, or else we're just going to throw a lot more garbage into space.
Exactly. Yeah.
So
that's why I'm not that keen about polluting low Earth orbit with more and more satellites, broadcasting reruns of Ishtar. You remember that movie, Alex? You remember Ishtar? Okay. So
I kind of have a vague memory of it being really tacky and cheesy. Am I hitting that one right?
Yeah.
It was like a step below, but Andromeda. Remember that one?
Yeah.
And then there was a lot of B sci-fi series and B sci-fi movies, but hey, it was entertaining, especially if you're on the nerd level and geek level that I am at.
Yeah, I have a pretty high tolerance when it comes to bad science fiction movies.
You let it slide, right? And then the science doesn't make any sense, and you're just, it's the movie. It's like, do we complain about the Marvel movies? It's just like, whatever, right? It's just, it happens. But on that note, my biggest question is what does NEG need to do to help you get to the next star system? Is there something, I know it's a big question. It's probably a little bit out of context, or really not really practical, but is there anything we could do as a community to support a project like this? Is this something that
the main thing is mainly just don't laugh when people talk about this idea. There's another cool idea that you probably heard of called the space elevator. I don't know if you ever heard of this, but we could actually deliver things to space by building this giant tether that goes up 40,000 kilometers. And the science fiction writer Arthur C. Clarke, who wrote 2001: A Space Odyssey, he was a big proponent of this. And someone asked him, when do you think the space elevator will be built? And he said, 50 years after everybody stops laughing.
Right.
And that's kind of where we are with interstellar travel now. If you say that in most scientific circles, or ask my colleagues at McGill, they just kind of laugh and say, oh, this is just ridiculous. It's just never going to happen, or won't happen for 300 years. So that's the main message we got to get across is, don't laugh. People are looking at this seriously. And the main thing is we have multiple paths to get there. I talked to you about plan A, B, and C. Right. So if one of those, there's a showstopper shows up, and okay, this is a dead end, right, and we can put our emphasis on something else. And I think eventually we'll want to do this because astronomers are going to be tantalizing us with saying, oh, we found this planet.
Yeah.
We found oxygen in the atmosphere. We've even
I'm already
found
tantalized. I'm
waste.
Tantalized. Yeah.
Like what happens when they start saying we find signs of industrial pollution in the atmosphere of this planet, but we can't show you what it looks like. Then I think people are going to want to say, well, can we go there? Can we send a probe there? So, and that's what we need to be ready for.
We're not alone.
So what we need,
it's incredible. Think of that psychological, it'll be like, what would that do to humanity? Like,
no, it's I like to think of it in these terms. Like the two biggest scientific revolutions,
right,
was Copernicus and Darwin.
Right.
Okay, so Copernicus told us we're not the center of the universe. We're just one planet orbiting one star. That started a whole cascade of things. Now we realize the universe is bigger than we can imagine. And then Darwin told us we're not special in the biosphere. We're all related. We're all part of one tree of life.
Right.
If we could discover life around another planet, it would be like Darwin times Copernicus. Okay, it would be like the square of that in terms of its impact. It would mean that there's life everywhere, and we're part of this tapestry of life that goes across the whole universe. So
the more you read about, excuse me, hold it. But the more you read, I'm just excited. I got to get this out. The more you read about science today, and the whole conversation about water, and how when or even in our planet, everywhere that there's water, doesn't matter if it's completely dark, the most hostile conditions, there's life there, right? So there's this whole idea that anywhere in the universe where water exists in a liquid form, there's life there. It's like that's like the essential building block. And then
but then imagine we find pollution there. I think that would be riveting, because you can find water, and I think what people picture is like little parasites in the water as life, and it's not like it's easy to still egocentric make humanity here like the center of the universe, and take that kind of approach if the other life is just like a little microscopic parasite thing in the water. But if all of a sudden we came across some industrial pollution, and it's like some other species that's just as bad at managing their planet as we are, that would make people go all kinds of everything back home. And if we just saw a proof of it, it would create such a big debate in conspiracy theory land. And I think that's what would really drive it all forward. Because until we're arguing about it at each other's throats with all the polarity in the world, trying to prove everything, we're not going to get that interest in the real science, which is the unfortunate current state of modern marketing and modern idea sharing. Is you got to argue with your neighbors about whether it's true before you're even going to care in the first place.
Okay, so, I'm gonna take to this next. Holden, thank you for that. I looked something up because I just had something I need to throw on this table related to this conversation. Stephen Hawking talked about this. A lot of people talk. It's a concern, right? That we become in contact with another intelligent, I'm really throwing this out there, okay? We come in contact with another intelligent life form, right? And I don't know if you're familiar with the book. I've just looked it up by Noah Harari. It's Sapiens.
Yeah. Oh my God, amazing book.
Yeah.
Amazing book.
He talks about this relationship where when, more advanced, more technologically advanced humans came in contact with less technologically humans. It's like the disease, guns, and steel was another book.
It didn't turn out too well. Usually those contacts were.
So what is your feeling on that? How do you from if we come in contact with another like intelligent life form that's creating pollution like us, is it gonna be a pleasant experience at the end game, or is it gonna be like, when Kirk discovers the Klingons, right? Is it just gonna be nastiness? That's the big
Yeah.
question, and I
So,
don't think
so it's gonna take me a minute to unpack this, but the thing to wrap your head around is the galaxy isn't that big, but the galaxy is way older than we can think about.
right.
Okay, so let me try and explain this. Is let's say even with a really crummy approach to interstellar travel, like let's say it takes 1,000 years to get to the nearest star. Okay,
Right.
and then you get there and you set up a little base and you industrialize and you extract what you need to build the next starship to get you to the next solar system, and it takes you 1,000 years to get from star to star. Within a few million years, we could have spread across most of the galaxy. Okay, but the universe is, our galaxy has been around for billions of years.
Right.
Okay, so it's like time is deeper than space is big. Okay, so what that means is any other civilization that's out there is probably way, way advanced past us, or they're still like bacteria. Okay,
Okay.
like we're not going to find an equal partner. We're not going to
Oh,
find the
I
Klingons
see.
and the Romulans, where when we battle, it's going to be, ooh, this is a close run thing.
Yeah, yeah,
They're
yeah.
either going to be way below us. Like if they only started evolving, 1% in time later than we did, then they're going to be, just crawling out. They're going to be creatures just crawling out of the ocean for the first time, and not a terribly significant threat. Or they're going to be where we would be forward, millions of years. And just think about the technologies and the weapons and the technology we have. So if we ever meet up, I hope they're friendly, because if they're more advanced than us, they're going to be way more advanced than us. So we don't really have a chance. So if there's a malevolent, you really have to be fatalistic about this. If there was a malevolent civilization out there that's more advanced than us, then they're going to find us and they're going to wipe us out.
Right.
So
Right.
there's not much we can do about that.
We
Or
beat
treat
done
us
already.
like cattle.
Yeah, but
Well-
if they're a million years advanced from us, they can, I doubt they're going to need us for slavery or for food or all the other scenarios
but
we see in science
entertainment.
fiction.
That's
But
what
imagine-
science fiction would put me at then, is we'd be the zoo animals for the
Yeah,
future
that would
Yeah, but imagine
pets,
the reverse. We arrive to a planet that's very early in its stages of evolution, right? Maybe
right.
down the road there's a maybe not a humanoid that like we see in Star Trek, but something that is created that's sentient and has the capacity to develop. But we arrive there before that all happens, and we just squash it under our feet, right? Because we build.
I would hope not. I mean, that's the one idea from Star Trek that I hope persists, is the
Yeah,
idea of the prime directive, that we would not interfere with a more
Yeah, but
primitive.
my point is, if we get to the planet when the things are just starting to claw out of the ocean, right? It's like, they're not even there yet, right? We kind of interrupted that evolutionary process.
Oh, that's why we're going to send a robotic probe first. We're gonna.
And then all of a sudden
And if
they
there-
find
and
the
if there's
robot
life there-
as their
if there's
humans
life
there.
there- If there's life there and there's water there, liquid water that we can drink, you're saying that we're not going to go there because there's
Yeah,
life?
I would think if there's life there, we would probably quarantine. There would probably be some kind of quarantine around them.
Oh, so you say even if there's like basic minimal life, you think that humans would make the decision not to go
Well,
to
I
that
mean, even
planet?
with the Prime Directive, you were allowed to go to the planets. You just couldn't interfere with their development. So, like in the same way that you would go into like the jungle or something and like
But
keep
how do
it.
you? I don't. We have to. I don't know how we would control that, but I think that once you get that gene,
Yeah, you leave like an artifact behind, and then all of a sudden, 1,000 years in the future, there's people there, and they find your like
And they're worshipping,
forgotten satellite
like, here.
stuff, and you've now created a religion
Who
on
built
this
the
planet.
pyramids? Who built the pyramids?
I mean, Stargate made some great points. Yeah. So it's likely, though, if there is life, that the statistical probability of it all is we're not going to encounter somebody that's equal to us.
They're like
Italy.
bacteria or gods. Okay, that's all we're going to
Right.
find out there. They're going to be like way beyond us or way behind us.
But is
And
in
we're
theory
just-
then, based on that same thing, if we wanted to just take it an extra step, so in theory there could be like a lot of godlike civilizations that have already formed like a galactic council and all this stuff, and they're just like
Yeah.
watching us on TV.
Yeah, we're like
I don't know.
There's a
I
South
mean,
Park
when
episode
people-
on that, by the way.
I mean, my answer is let's go find out. Okay, let's go out there and see what's out there, because
We're a reality TV show for aliens. That was actually a South Park episode.
It's amazing.
It was a ridiculous episode. But on that note, I do have a favor to ask of you, Andrew. Would you be Trainman's official like science guru? If there's some sort of science thing that happens that impacts the community, could we call on you? Like have a red phone?
if an interstellar vessel lands,
we need you here and we need you now.
yeah, if a alien spaceship lands in Confederation Park,
Well, no,
Alex,
say
you got
for
my number. So
a solar storm or anything like that. We have an eclipse coming up. Is that something
Yeah.
that's of interest to you and your community? Are you guys?
yeah,
following
yeah,
that?
yeah. So I mean, if there's things that fall within my domain of expertise, I'd be happy to talk. Usually in engineering, we kind of like there's this sort of stick to your swim lane
Oh,
mentality. And
Yeah,
I don't
for
like to speculate too much about things I don't know about. But yeah, if there's things you think you would benefit from my input on, I'd be happy to join you again.
I saw pictures of you guys like actually launching rockets. Is that something that you guys do? You build and launch rockets around? Is that like an
Yeah,
actual
at McGill
thing?
we have it's undergraduate students now. This is a huge thing on campus. We have undergraduate students that essentially self-organize and build rockets, and they traditionally go in the U.S. There's a competition that's held every year in New Mexico. But we now have a Canadian launch site up in Northern Ontario.
Oh, so cool.
There's a competition. So I went with the students last summer. I'm like their faculty advisor, but all I do is sign the paperwork when they need to spend money. I don't do all that much, but it's there's really a lot of interest in space on campus these days, and it's not just McGill. It's every university. It's the students. They're really stoked. I mean, they're really excited about what's happening in space, and there was kind of this pent up feeling for a long time that our space program had kind of stagnated. All the big government space organizations had become a little bureaucratic and risk adverse, weren't innovating. And what's happened in the last 10 years has just been exciting. And students, they really want to be a part of this. They're very, very enthused about this.
Yeah, there's like a space race going on right now. You've got Elon, Jeff Bezos.
Yeah.
It's
Richard
pretty-
Branson.
If I'm not
all these
mistaken,
people, yeah.
India's government also has one of the strongest space programs right now.
Yeah, I mean, they're getting ready to send, probes to the moon, talking about probes to Mars, and so
Supposedly, their probe to the moon cost less than the movie with Sandra Bullock. What was it called? There. Oh, please help me.
Interstellar.
She did Interstellar. Yeah.
Gravity was the one with Sandra Bullock.
Gravity.
right?
Yes, that's.
Oh, my
yeah.
bad.
Yeah. So on that note, I want to just reach out to our listeners and make the note that Andrew Higgins is one of us in NDGer, and we should all be very proud of the work he's doing at McGill University. And once again, our community is made up of many individuals like this who have really cool and interesting things to share. And I can't tell you what a pleasure it is as someone who's fascinated with space and all things nerdy and geeky to have him on our show and discuss interstellar travel. I think it's just like blows my mind away. And as you can see from this interview, we touched a lot of different subjects, didn't we, Andrew? We talked on antimatter, solar winds. We even talked about, encounters or first contact with alien species and what form that would take. And I just get tickled pink at how these conversations and the directions they take. And Holden, you're doing just an awesome job hosting and helping us with this. And Andrew, this is something we're trying to build. We're trying to build a community project here. This is what this podcast is all about. And I want to thank you for your kindness and your patience and making yourself available. And also for agreeing to be like our science council when necessary in community
He's like,
emergencies.
I'll be your science counsel, but only if it's related to space and all the things I know about.
Fair enough, and that we can't ask more from him. So I just again thank you so much. and I hope to see you soon. And I wish you and McGill and your grad students all the best. And I know, I know with 100% certainty that if your McGill or your students would love to engage our young, young-minded scientists or interested youth, I'm sure that you would have an audience here, and I'd really be interested in helping you with that project if it
Yeah.
should come to that. Yeah.
Sure. Yeah. No, this has been a blast, guys, and
Do you have any
I
like?
love our community, and I really admire what you're doing. The energy you guys have to
Do you have any
cement
like
our community.
minute, like anything you want to close on or advertise or promote that's
Yeah.
interesting? Because like you
No,
are
no.
at McGill or anything, I don't know if any programs or stuff that could be, because like like Alex said, we're trying to create like a community platform and advertise a bit what's actually happening here. I know McGill's technically not an NDG, but still it's pretty adjacent, and like what you're involved in is there like,
And we have
like
we have a lot of McGill professors here. My gosh, I have like 6 professors in my department that live within 6 blocks of me here in NDG.
Nice.
Really?
I would just encourage everybody to be welcome, always welcome on campus. Anybody who wants to visit my lab, you can find me online, shoot me an email, and I'll be happy to give you a tour of what we're working on. And
That's so
it's
kind.
actually not a bad thing to do. Is just walk into a university, find an open door, and just knock on the door and just ask people what are you doing, what are you working on, and what's the worst they can do is they'll tell you to go away or something. But somebody might there's a lot of cool stuff going on, people doing all kinds of really innovative things, and
Right.
we're part of the community, so people should feel welcome to come on campus. And
I hope
see what
there's
we're
some
doing.
high school teachers or elementary school teachers who are listening to this podcast, because I think that would be an excellent exercise. Again, kind, gentle. Thank you for your patience and your time,
yeah.
of course.
And thank you to everyone that's watching it too. Like we have Shelly Boomhauer Slater in the comments saying that she enjoyed this. So it's always great to get that kind of feedback from people. So definitely leave us comments, letting us know what you thought. Definitely share this with your friends. The only way for our very NDG centric show to grow is going to be for you to share it with the people who care about NDG. That population is us, so it's we are putting our faith into you, the fine listeners and watchers, to spread the word about what we're doing here, but also to invite you onto the show, and so that you can come and speak about what your life is like, and we can cover a lot of things, because it's not just bike paths over here. We care about all the topics. It's and we'll soon be launching something like a Patreon and things like that. So if you have any ideas of what you think could be interesting rewards, let us know. And if you want to get involved in any way, also let us know, because we definitely will need a street team of sorts to help us accomplish our bigger visions. So thank you all for watching. Make sure to hit that like, subscribe, all that good stuff. Share it again with your friends. Appreciate you, Andrew, for coming and sharing all of your good stuff. And live long and prosper, everybody
Long
out
and
there.
prosper. Yes.